Hey guys, I'm a little bit nervous about the 15 minutes on this one, so I'm going to kind of skip the formalities at the beginning, even though by saying that I didn't really do that. But for questions 1 to 4, we want to draw this given angle, and then find a reference angle, find the cosine and sine of the angle. So the first thing I like to do when looking at this stuff is take a look at the denominator of the angle at which we're trying to find the cosine and the sine of, and I'm going to put my major endpoints in terms of that denominator. So I know that halfway around the circle, so the first top half of the circle, that's going to be 1 pi radians. So if I want this fraction to reduce to 1, let's make this numerator 6. And if I go all the way around the circle, that's 2 pi radians, so let's make the numerator of this circle 12. So we have 1 pi and 2 pi, but now it's in the same denominator, or common denominator, as our given angle. Okay, so we want to go 23 pi over 6. So here's 6, here's 12. Well, we have 11 more. So 6, this would be 24, so we want to come back 1 pi over 6. So we wanted to come back 1 pi over 6. We went around the circle once, and then almost twice, but we have to come back a little bit. So now we want to find a reference angle. Our reference angle is the angle in the first quadrant that we know the cosine and the sine of. Our reference angle is equal to pi over 6. Now there are a couple ways for us to know what these coordinates are. One of them is to just have that unit circle memorized, or we can take a look, and if we think about going from this point to the x-axis, does that look like it could be 1/2 of the distance from the origin to here, and then the distance from here to the end point? Or rather, if we go to the y-axis, does that look like it could be 1/2? So if we draw our line over to the y-axis, that looks like it could be about right in the middle between the origin and the end point. So my 1/2 is going to go with the y component, and then we got square root of 3 over 2. So the cosine and the sine of the angle that we're working with, so the cosine of theta and the sine of theta, well, here the x value is going to be the same, so square root of 3 over 2, but the y value is going to be negative, so we get negative 1/2. Okay, 13 pi over 4. Okay, first thing we like to do, denominator 4. Numerator, we'll keep that 4 over 4 to make it 1. Denominator 4, 8. So now we have to go 13. So 13, we have 4, 8, 12. Well, that must be one more. The reference angle, ooh, fishy. The angle in the first quadrant at which we know the cosine and the sine of, and the coordinates of that point, square root of 2 over 2, square root of 2 over 2. So the cosine of our angle and the sine of our angle, if we're moving that to the third quadrant, negative root 2 over 2, negative square root of 2 over 2. Now the only difference with negative angles is we're going around the circle in the opposite direction. So here we're going around in the clockwise direction. So this is still going to be 3 and this is still going to be 6, but we want to make those negatives. So let's count. We've got negative 3, negative 6. This would be negative 9, so let's dial it back 1 more pi over 3. The reference angle is the angle in the first quadrant that we know the cosine and the sine of. So our reference angle, pi over 3. Now this one's easy to see because if we drop this down, we know that that's the angle with the x coordinate, 1/2, and then the y component, square root of 3 over 2. So the cosine of our angle and the sine of our angle, again, if we're in the third quadrant, we're going to make both of those SIGNs negative. Negative 7 pi over 2. A couple ways that we could do this, but let's stick to the plan, man. So if our denominator is 2, then this would be 2 pi over 2, and this would be 4 pi over 2. So let's count to 7. 2, 4, 6. Well, 7 must be 1 more pi over 2. So let me just make sure I counted that right. We got, whoa. 2, 4, 6, 7. Yep. So now, what is our reference angle? Well, what's the angle in the first quadrant that we know the cosine and the sine of? I think that we know the coordinates of this point are x value 0, y value 1. So our reference angle, pi over 2. The cosine of our angle and the sine of our angle, x value 0, y value 1. Okay, so now to draw a sketch of this function, let me see. Whoa. Losing precious minutes here, man. Okay, so to draw a sketch of the function, the things that we want to find, we want to know what is the amplitude, which in this case is 4. We can see from the equation that the frequency is pi over 4, so that would mean that p is equal to 2 pi divided by 4 over pi, divided by pi over 4, which is the same as multiplying by 4 over pi. The horizontal shift and the midline. Well, this is not yet in standard form, so if we started with 3 pi over 4 and we divided out by pi over 4, our horizontal shift is 3. And it's going to be to the right 3 because of that minus sign. The midline, positive 3. And then we also like to find something that I like to call the scale. It's the distance between, the horizontal distance between those major points. And you take the length of the cycle and divide it by 4, which is 2. Okay, so now that we have this information, let's draw in the midline and indicate where the horizontal shift is. So the horizontal shift is to the right 3 and up 3. Now think about what we're graphing. Cosine starts at the maximum. So if our amplitude is 4, 1, 2, 3, 4 is where we're going to have a point. Now the reason why I like to find the scale is because every 2 units we're going to be back to another major point on the circle. 1, 2, 3, 4. 1, 2, and then up 4. And then to go over to -5, if we're at the top, go 2 units to the left, back to the midline, 2 units to the left, down to the minimum, 1, 2, 3, 4, 2 units, back to the midline, 2 units, and then back to the maximum. Let's see how I draw with this little guy here. Mona Lisa-esque. Alright, so what I would like to do now is think about that equation. And when I wrote it in standard form, I have 4 times the cosine of pi over 4 times x minus 3 plus 3. And we want to find out when this will be equal to -2 square roots of 2 plus 3. So the first thing I see is that these 3's are going to cancel, and then we can divide both sides by 4. So dividing both sides by 4, I'm going to need more space, so I'm going to have to zoom in. Dividing both sides by 4 is going to leave us with the cosine of pi over 4 times x minus 3 is equal to negative square root of 2 over 2. Because if we divide this by 4, those cancel. Dividing this by 4, this cancels and leaves us with a 2 in the denominator. Okay, so now we're at a place where we want to say pi over 4 times x minus 3 is equal to, and pi over 4 times x minus 3 is equal to, I like to draw a circle. And I know that the SIGN of this is negative, but cosine is the x value. So what angle in the first quadrant has an x value of the square root of 2 over 2? Pi over 4. Because I only really know my first quadrant angles. Then I can say, if I need my x value to be negative, well, that will be in the second quadrant and the third quadrant. So here our x values are negative. If the denominator is 4, keep this numerator 4 to make that 1, and then in the second quadrant we'll come back 1 pi over 4, and in the third quadrant we'll go 1 more pi over 4, so 5 pi over 4. To solve, let's multiply by the reciprocal, times 4 over pi. X minus 3 is equal to 3. Multiply by 4 over pi, times 4 over pi. X minus 3 is equal to 5. Adding 3 to both sides, x is equal to 6, x is equal to 8. Now notice that this says on the interval from -5 to 9. The length of the cycle, p, was equal to 8. So if we subtract p, which is 8, from 6, we'll get -2, which is still in our domain, in our interval. And if we subtract 8, we'll get 0. Okay, last one. It's going to be close. Okay, first thing we want to do is divide both sides by -6. Divide both sides by -6. 3 and 6 are going to cancel. So 5 times... That's not right at all. This 5 is inside. So the sine of 5 times x plus 2 pi is equal to -square root of 3 over 2. This is that point where it's nice to draw a circle and know that we're going to have two equations. So 5 times x plus 2 pi is equal to, and 5 times x plus 2 pi is equal to. Now, which angle in the first quadrant has a y value of the square root of 3 over 2? That angle in the first quadrant is pi over 3. So if our denominator is 3, let's make this numerator 3, and this numerator will be 6. We need the y value to be negative, so that's going to bring us into these two quadrants so that the y value is negative. 1 more than 3 is 4 pi over 3, and 1 less than 6 is 5 pi over 3. Divide both sides by 5. So times 1/5 times 1/5, x plus 2 pi is equal to 4 pi over 15. X plus 2 pi is equal to 5 pi over 15. And I know that I'm rushing. Now we need to subtract 2 pi from both sides. So when we subtract 2 pi from this side, we'll get x is equal to minus. Now think about the denominator having to be 15. So this numerator, in order to keep that 2, will have to be 30. So we'll get -26 over 15 pi. Subtract 2 pi. But when we subtract 2 pi, we want to subtract, again, 30 over 15. So we get x is equal to -25 pi over 15. Don't forget to add in the length of the cycle, which 2 pi divided by b as many times as we want. 2 pi divided by b as many times as we want. That's how you debate.